Hello, this is video F. Yes, we're still looking at basic C++ syntax, building up our toolbox. We've almost got enough pieces that we can put them together and do some stuff. For this one, let's look at input and output. And I'm sure you will recall that the input that we will be most interested in, at least initially, is the keyboard. That's how we type stuff in. And the output's going to be the screen. That's where we send stuff. I'm going to start with output. Get the slightly more complicated piece of this out of the way first. The format for doing output in C++ is to use cout. It's spelled C-O-U-T. It looks like count, but it's actually pronounced cout. All one word like that. And then you put two less than signs in a row. That's the output operator. And then I'm going to use one of my pointy bracket tokens over here and call it output list. So it's cout, less than, and then output list followed by semicolon. The effect of this, I'm going to back up because this is a pretty big effect. Here's the effect. Output list is printed to the screen according to these rules. What's the rules? Here's the rules. Rule number 1, strings in double quotes, which is how you indicate what's called a literal string in C++. What you see is what you get string, and that's what we're going to see on the screen. Strings in double quotes are printed. We'll bet about the only Latin I know, verbatim. Clean that up a little bit. Strings in double quotes are printed verbatim without the quotes. So you have to put quotes around it so the compiler knows that this is supposed to be a literal string and you want to see that string on the screen, for crying out loud. Don't try to translate it or evaluate it or anything. So you put it in double quotes, but the double quotes themselves are not printed out when it shows up on the screen. Rule number 2, each variable expression, I'll hold this up here, expression, symbolic constant, which I think I've mentioned more than once, and I haven't said what it is. I think that'll probably be the next video. Each variable, expression, symbolic constant, etc., all this other stuff that have values and we don't put them inside double quotes, those are evaluated and then the values are printed to the screen. Each of those is evaluated. Then its values printed to the screen. It being whichever one of these we're talking about. Its value is printed. And I'll assume it goes without saying that it's to the screen. That's the only place we're going to be printing stuff right now. 3. 1, 2, 3. Strings and double quotes, printed verbatim. Variables, expressions, yada, yada, yada. Those are evaluated, and then the values printed to the screen. 3. The reserved word ENDL. Stare at that carefully. It looks like end 1 when you type it in. That is very pesky. Leads to very subtle, very frustrating errors. 1 and L are very different characters. This is end L. I suppose it's abbreviation for end line because that's what it does. The reserved word end L ends a line of output to the screen. And I said I wasn't going to write to the screen anymore, and I forgot already. Ends the line of output to the screen. In other words, it goes to the next line. Okay? Now, I wrote so big and used board space so inefficiently that I don't know if I had room for an example, but I'm going to switch colors so that it stands out from the description and see if I can squeeze an example. You know what? I'm just going to allocate this irregular board space over here. There. Now I have all this board space for an example, which I shall boldly make up as I go along. Example, int dog equals 5. Now we haven't seen one like that before. We have seen variable definitions where I say something like int dog or double dog. That's an even better variable, isn't it? Double dog, except this is int dog. But you can go ahead and give it an initial value. That way you're guaranteed it's not going to be garbage if you tried to use it too soon or whatever. Another variable, int cat equals 0. No, I won't do that. Cat equals 10. Wow, the dogs are outnumbered. Int cat equals 10. So far I haven't produced any output. Let's produce some output. Cout less than dog. Now, let me pause and reflect on this and introduce something else in this example since I've started this column over here with no space to go to the right. In C++, one of the benefits, if you want to think of it this way, an advantage of a semicolon is that the line itself that's fed to the compiler, your line of C++ code, is not officially over until you hit the semicolon. What on earth does that have to do with anything we're doing right now? Well, I don't have room to write out the entire cout statement that I want here. Maybe, let's pretend like I just got a really narrow screen in a gigantic font. Then I don't have to finish it right here. I can actually drop down to the next line and keep going, and it's still going to be part of the same line. You know what? I'm going to make this a string. Change this already. Cout dog is, close double quotes. Then I'm dropped down to the next line, and I have to put less than again. All the stuff in output lists that you want to print out, they have to be separated by these output symbols, less than. So this will print out the string dog is, and then I'll print out the value of dog, and another less than, space, cat is, close double quote, less than, cat, and another less than. This is all one line in the mind of the compiler, the point of view of the compiler, the one that's responsible for changing this to machine language so it could run. Here's the first line, int dog equals 5. Second line, cat equals 10. Third line is still going. How is the compiler supposed to know it's still going? Because it hasn't seen the semicolon yet. So it's going to be dog is in quotes and then dog, cat is in quotes and then cat, and then down here for the grand finale, and dog plus cat is. Ooh, that was a long string. Well, we can handle it. I mean, strings can be arbitrarily long, more than you would possibly want to type. You could put in the entire text of a Shakespeare play if you wanted to inside double quotes, and it's all one string. Dog and cat is, got to put the mother may I, another less than symbol, and then I'm going to print out dog plus cat less than, finally, mercifully, an end line, ENDL. That's what happens when I make up stuff as I go along. They turn out to be much more complicated than they were in my mind. So somehow or another, translating from mental image to actual on-the-board example. By the way, I can now end line 3 down here. All of that is line 3 of C++ code that we're sending to the compiler. Now, the trace of this, there's not a whole lot to trace. Trace just means we put down all the variables as they show up and keep up with their values. This time, dog, a new variable, it does not start off with question mark symbolically representing garbage. It starts off with 5. cat. When we set up variable cat up here for us to use in our C++ code, it has initial value 10. The output that's produced, I'll label that output, which really is what we're here for. So finally, I'm going to quit messing around, C out, and here we go, less than, and now we've hit the output list. All this stuff is one big output list. Dog is, except that's in double quotes. It'll be printed to the screen as dog is, but without the double quotes. The double quotes are there to tell the compiler, I want to see that on the screen verbatim. In other words, exactly as shown. Don't try to evaluate it or anything. The next thing in the output list is dog without any quotes or anything. So the computer goes scrambling around looking for some variable or something named dog, and there it is. We set up a variable named dog in memory, and it's got to find the current value of dog and then print that out, and it will be 5. Look what we did there. Not only did we print out the variable value of variable dog, we printed out a label for it so that fearless user, when they're running this program, they can look at this and see what we're seeing. They're seeing that the current value of variable dog is 5. We do the same thing here, and notice I put a space in front here. That's not by accident. You don't want your output to look all cramped and squashed together and unprofessional, so I printed out a space, which will print out, and then cat is. See what happened there? There's also a space after is, even though it doesn't look like it. And then again, here's another piece of our output list that's not inside double quotes. So the computer tries to find a variable named cat, and there it is. It has value 10. So far, we've seen examples of each of these. Strings and double quotes printed that too. Verbatim, variables, printed out the value of variables. And here's the grand finale. And dog plus cat is. Here's some food for thought. Is Dr. England, your humble narrator, is he just printing out all that together in one big line because he didn't leave himself any space at all at the bottom of his whiteboard? Well, that possibility is not excluded, I suppose. But actually, all this will be printed in one line on the screen. Why? Why? Look at this. It's almost like a column over here instead of a line. It's because the system, the computer, has not seen its instruction to go to the next line yet. We're barreling that direction. We're going to hit that eventually. But until it hits an inline, even if it's separate cout statements scattered throughout a program, it's not going to finish printing on one line, picking up where it left off, and go to the next line until it hits that ENDL, the end line. So here we are so far. Dog is 5, cat is 10, and dog plus cat is, and look at this. That is not a variable. That is an expression. It's an expression that has to be evaluated based on rule 2 before it's printed out to the screen. But it has to look up the values of variable dog and cat. Dog is 5, cat is 10. Dog plus cat is, therefore, 15. Finally, mercifully, we hit the end line, which means now go to the beginning of the next line. Now, I don't have any other couts over here, but if there were another cout, then the very first thing printed out would be lined up over here in the first column underneath dog. What could be simpler? Well, I always say that ironically. I know there are lots of stuff that's simpler, but look over this and see what questions you can dream up. This is the kind of stuff, we're getting close to the kind of stuff where one example is just not going to cover it. And that's why you'll want to come to office hours. The first office hours will actually be today at 11 o'clock, and I'll be on call. You can come by and ask about videos, whatever you want, but don't let those questions bother you. Actually, I would say step number 1, by the end of this week, we will be running C++ code on our very own computers, believe it or not. Step number 1 would be, well, let me see, what would happen if I actually put a minus sign there? That's not a big change. But if you're curious about that, then do it. Technically, this is a lab course. You're supposed to be experimenting and finding out for yourself what happens when you change stuff like that. What happens if I put inline after every single one? Try that and see what happens. What happens if I don't put any inline at all? What happens if I forget one of the less than less thans? I might be able to cough up some answers to those questions, but I would say step one is to try that out yourself. Go in and alter your code for a C++ program that you're working on and just see what happens when you make the change. It'll sink in a lot better than if I just kind of make up some answer and tell you. Step two would be to come to office hours and ask me about it. If you've tried and failed to come up with an answer on your own, then maybe what I might do, I'll warn you, I might answer a question with a question and say, well, what happened when you tried this? And if you haven't, then go try that and let's get back together after you've done that. I'm just kind of devious that way. There, I've completely filled up the board, accidentally put an equal sign down there. Here I go again. I can't help it, it's in my nature. Any questions? Okay. Let's say that we've covered output, so now we can look at input. One moment, please. Input. Input is a similar but different format. It's like they're twins almost. The format for input is not cout. Oh no, it's cin. That's not pronounced sin, even though it's spelled cin. It's pronounced cin. And this is a common error to make, but you'll get over it. You'll figure out what this is and never make that error again. Less than don't go here. Greater than do. How can I remember which goes with which? Well, think of it this way. It's like we're going to be getting things from cin and putting it into whatever shows up over here. Now, what shows up over here is not going to be an input list. We're not going to read a list of one things. We're going to read a value for one variable. So my pointy bracket token over here is just variable. Wobbly variable. I've got to learn how to hold the board and write at the same time, at all times. Cin into a variable. Look how those arrows are pointing at the direction of data movement. It's coming from the keyboard, landing in the variable. And I didn't make that observation before, but you can go back and make it yourself. Cout, we're taking stuff from the inside of the computer and sending it to the cout over here on the left-hand side. Or at least that's how I think of it. The format for input is that. What does it do? The effect? Pretty simple. This is actually simpler than output. Reads the next value typed at the keyboard KYBD, abbreviated, KYBD, keyboard, into pointy brackets variable. I told you, there wasn't much to that. I could even slip an example up here. So much space wasn't used. Example, let's use double, just to mix it up. Double, I can't use double dog, I used dog in the last example. Double bubble. There we go. Now I've got a variable. I can't read something from the keyboard into my program unless I've got a variable where I'm going to hold it. Now, we already know how to do output, so just to get good habits started early, I'm going to use output. Notice the arrows point the other direction. I'm going to send this to the output, and I'm going to send what we will call a prompt. Tell the user what you want, for crying out loud. Otherwise, they're not going to know what they're supposed to type. And I'll just make this simple. Bubble, colon, double quotes, semicolon. I'm going to stop talking like that. Now I can do my cin statement. Cin greater than, bubble, buble, bubble. Now, Let's see what happens. That's not much, but still stuff will happen. Here's a trace. Over here, I'll keep up with the output. Not much of either one, really. Here's my trace. I've got one variable named bubble. So I don't forget, bubble does not have an initial value. Garbage, represented by a question mark. I don't know what's there. It's some random garbage value. The output, well, there is output produced. Bubble, colon, space. Oh, you caught me. Ugh. Bad, Professor. I forgot my less than C out. I'm not C out, but indel. Go to the next line. You know what? I did that on purpose. Fooled you. I don't want it to go to the next line. I want to print out bubble and a colon and a space and have this blinking cursor right there. All primed and ready and waiting for the user to type in some number. And they type in 1.23 at the blinking cursor and press enter. Okay? All of that was just this line. Well, not exactly. What this line did was just print bubble, colon, space on the screen, leave the cursor blinking on the same line. I don't even need an inline for this example because the user, him or herself, is actually going to type in 1.23 and press enter. That enter will take me to the next line. Until they press enter, they can change their minds. They can say, well, I didn't mean 1.23. I meant 1.32. So they get a little think about it time over here to backspace and change this value. But as soon as they press the enter key, they've made a commitment. And 1.23 is going to be read into the program, and in this case, in variable bubble, 1.23. And there you have it. I'm trying to milk this example for all I can because it's just so small. There's not much to it at all. So I will lean on you to come up with all kinds of what-if questions. What if there's more than one variable here on the line? Well, actually, I hate to break the seal on this. You can do that, but that gets really complicated in terms of keeping things straight in your program. And remember, one word that we want to use to be able to describe our code is robust or bulletproof. Hard to crash, in other words. If you say type your name followed by a number for bubble and all that complicated prompting, you try to read it in a bunch of variables at one time, very often that's not going to work correctly. They'll get values of the wrong type typed in and all that stuff. So it's just very good programming style. It's not too soon for us to talk about style. To ask for one thing, read one thing. Ask for another thing, read another thing. A little back and forth dialogue with the user. Rather than saying, type in your name and address and age and your entire life history and all that stuff in one prompt and then have a bunch of variables down here. Oh, no, that's a no-no. That is asking for trouble. And we don't need trouble. We already got bubble. Oh, man. That is awful. I'm sorry. Okay. Now, it's almost done. I'm almost done with this. So almost done. I'm not even going to take the time to erase the board. Down here, I am going to put a big note. Big note. Exclamation point. Underline. Colon. I'm even tempted to put a gold star next to it. I think I'll reserve that for when I really want to use it. Using C out and C in requires REQ apostrophe S requires this at the top of your source code. Top up source code. I'll take out the articles. Saves time. Not Dode, no, code. I give time for the ink to dry while I change colors yet one more time. Using C out and C in requires this at the top of the source code. And I don't like saying this, but just do it. I'll talk about it, but you don't even have to understand that. All you got to do is remember to do it. Pound sign or hashtag or whatever you want to call that. Pound sign include space, then pointy bracket, and in this case the pointy brackets, unfortunately, even though that's what we have to use, this is not a token, this is the real thing that you actually type in. Pound sign include IO stream, close pointy brackets, And then the next line beneath that, using namespace STD, semicolon. I'll read that back because it's important that that is exactly there verbatim. The good news is you don't have to figure this out so you can alter it for different circumstances. It's always going to be exactly like this. And I could go off and make a whole hour speech about what it means to have the pound sign in front, what the pointy brackets mean. It's actually a special case of string instead of using double quotes, yada, yada, yada. What this is really doing, here we go. This is alerting the compiler that we want to use CN and Cout, which are in the IOStream library. Remember the word library from a previous video? That is separate code that the nice people at Microsoft or Apple or wherever wrote for us that we want to use without having to write it every single time ourselves, for crying out loud, whenever we need to do it. Where's the library stuff? This, CN, Cout, those are part of the input-output stream, where stream just means flow of bytes coming in from the keyboard or going out to the screen, whatever. We want to use that CN and Cout out of this library using namespace STD. You know what? That is even more cryptic and complicated than that line. So I hate saying stuff like that. Like I said, just get these right and make sure they're at the top of every program. What if I forget? Well, if you forget, the compiler is going to be more than happy to tell you that it has no clue what CN and Cout are. You won't be able to use those in your program unless you have these two lines. And I'll do a hand wave description of this. Using namespace STD, STD is short for standard. It turns out that C++ is so big, it's like the ocean, that they run out of symbols, and things like CN, Cout, those could mean different things in different contexts. This is just tying it down and saying, using namespace STD says, just use the plain, the standard interpretations of these things. Don't worry about getting fancy, where CN might mean read it from the internet rather than reading it from the keyboard. Don't do stuff like that. My description for using namespace STD is like, if we go to my family reunion, we're using namespace England, then we got a cloudy namespace. If some messenger boy shows up and says, telegram from Mr. England, then just about everybody's head is going to turn. We don't know who they're talking to. If they come into my house with just me and my 5 dogs and say telegram from Mr. England, there's no ambiguity. My house is a namespace. Using namespace Dr. E's house, then my name would be unambiguous in that namespace. That's already more than I intended to say about that. I'm sorry, I'm rambling on. I had 2 cups of coffee already. But I'll try to seal off the wound there, and we'll go on to other stuff. How's that? And I'll see you online.